Okay, today we're going to talk about graphing inequalities and linear programming. Linear programming is used in real life a lot of times, especially in factories or places where there's restrictions on how much something can be done for a profit. Okay, linear inequalities with two variables. First thing you need to know is the less than sign, and when you graph it on a graph, it's a dotted line and it's shaded down. Dotted line meaning that anything on that line is not part of the solution. Shaded means everything in the shaded area is part of the solution. A less than or equal to sign is a solid line shaded down, meaning that everything on the line is part of the solution and everything shaded is part of the solution. Greater than is a dotted line shaded up, meaning that anything on the dotted line is not part of the solution and everything shaded up is part of the solution. Greater than or equal to. It's a solid line shaded up. Everything on the line is part of the solution. Everything in the shaded area is part of the solution. Your calculator, if you have a TI-83, can graph with shading for you. What you need to do is this. You go to the front of the y of 1 or whatever. You hit enter. That makes a solid line. A big thicker line, not a solid line. That is your greater than, so it will shade everything up for you. Enter one more time, that is your less than. That will shade everything down for you. So a less than, down, less than or equal to, down, greater than, up right hand corner, greater than or equal to up. Now here's the problem. Your calculator on a TI-83 will not distinguish between a dotted and a solid line. You have to determine if it's dotted or solid yourself. You're just going to see the same line with a less than or equal to sign. Okay, so the first thing you have to do is you need to change it into y equals mx plus b. So negative 3y is greater than or equal to negative 2x plus 6. Divide by negative 3. When you divide by a negative number, the sign is going to switch directions. Remember that. From our previous lessons, we're going to start at negative 2 and place a dot. We're going to rise 2 and run 3. 1, 2, 3. It's going to be a solid line. And y is less than, so it's shaded down. Let me show you what your calculator will show you. Okay, we have greater than, so I'm going to go back through my enters until I get to the greater than. Oh no, I need less than. Okay, less than 2/3 x minus 2 graph. Now what will happen is you can see it's wonderful. It graphs for you. It puts your coloring in, but you can't tell if that line's dotted or solid. It doesn't show. So pick up my 4x and move it over. So negative 2y is less than or equal to negative 4x plus 8. Divide by negative 2. Y, switch the sign, is greater than or equal to 2x minus 4. So go to negative 4 and put my first dot. 1, 2, 3, 4. And I'm going to rise 2 and run 1. It's going to be a solid line. And y is greater, so it's colored up. See how that looks on the calculator. Okay, so I'm going to go out front again. I need to get to greater than. And my equation is 2x minus 4 graph. So you can see it's colored up. So it'll help you with your shading, but it won't help you with your dotted or solid line. So you have to make sure that you understand that if it's a less than or greater than, it's a dotted line, and everything on the line is not included. If it's a greater than or equal to, or a less than or equal to, it's a solid line, and everything on the line is included. Okay, so let's graph some of these. This starts at 0. It goes down 2 and over 3. It's leaning to the left, which it should. It's a dotted line because there's no equal to sign on it, and it's colored up. So it means everything in the shaded area is part of the answer. The dotted line is not part of the answer. This one, nothing's on the back, so it starts at 0. It drops 3, goes to the right 4. It's negative. It's dotted because there's no equal to sign, and it's less than, so it's colored up. Now remember, this coloring goes on and on and on, so it's not just where I color, it's anything under the line. This is a horizontal line, a -3. It is solid because it has an equal to, so it means everything on the line is also part of the solution. Y is less than, so it's colored down. This is a vertical line. It goes through 2. It's dotted because it doesn't have equal to, and x is greater, so it's colored to the right. Now, we're going to be graphing things that have more than one line, and we're going to be looking at where they overlap at. So that's what we're going to be doing next. First thing I'm going to do is move over my x, and I'll divide by -1. When I divide by a negative number, remember the sign switches directions. I'm going to pick up my x and move it over. That becomes negative. Divide by 3. I'm not dividing by a negative, so my sign will not switch directions. These are the two things I'm going to graph. I'm going to graph them in different colors. Okay, so I'm going to go to -1 and put a dot. I have a slope of rise 1, run 1. It's a dotted line, and y is greater than. I don't normally color when I have to do 2 of them and look for overlapping. I put arrows. The reason I put arrows is then I can color where they overlap and I won't have all this coloring. Okay, the other one starts at +4, 1, 2, 3, 4. It drops 2, 1, 2, and goes over 3. It's a solid line, and y is colored up. So as you can see, my coloring is going to be in here. Because that's where it overlaps. Now, I always get a question like, okay, one's dotted, one's solid. So is this overlapping point part of the solution? The answer is no. It's not a part of the solution for the dotted line. Therefore, it cannot be part of the solution for the both equations. What the solution is on this equation is anything in the shaded area and anything on the solid line, but not on the dotted line. So that intersection point is not part of the solution. Now let's see what it looks like on a calculator. So y equals, clear it out. I need to do y is greater than, so go out front and let's get the greater than sign, x minus 1, and y is greater than, let's get the greater than sign, of -2/3 x plus 4. Let's graph it and see what it looks like. Now they're going to shade everything, but you're going to see an overlapping where it's a lot darker where the two of them are. That's where the answer is. So the answer is here, and my answer was here. So your calculator can be a great use for you when you are doing these, because they can help you make sure that you're correct. Okay, next one. Move the x. Divide by -3. Y is greater than, because the sign switches by dividing by negative. Remember, this has a 1 here, so -1 over -3 is 1/3 x minus 2. Pick up my x and move it over. I get 3y is greater than or equal to -2x minus 6. Divide by 3. Y is greater than or equal to -2/3 x minus 2. Okay, so let me get some colors. -2. Down 2 and over 3. Solid. Y is greater than, colored up. -2. Up 1 and over 3. Dotted. Y is greater than, colored up. Here's my shaded area. So everything in that shaded area works. Anything on the solid line works for the one, but not for the other. Okay, what if we have more than one? Well, then we have more than one. We start graphing more than one line. We did 2, now we have 3. So I'll pick up my x and move it over, and again, -y is less than -x plus 2. Divide by -1. y is greater than x minus 2. There's my first one. This one is all ready to go. This one's all ready to go. So I'm ready to graph. Starting with my pink line. Down 2, up 1 over 1. Dotted. Y is greater than, so I color up. My purple one. My purple one are 2 vertical lines. One vertical line is at -2 and it's solid. And one vertical line is at 4 and it's dotted. And X is in between, so I'm coloring in between. So I'm looking at right here right now. And my blue one is a horizontal line at 3 and it's dotted and it's colored down. So evidently my answers are in here. Again, x over y is less than -x plus 2. Ready to go. Ready to go. Ready to go. So let's start with this horizontal line at -3. 1, 2, 3. Dotted, colored up. The pink line, 2 vertical lines, both dotted, one at -2 and one at 1. Colored in between. My purple line starts at 2, 1, 2, down 1 over 1. It is dotted 2, colored underneath. So evidently I'm looking at this space right here. Now, why do we need this stuff? Well, believe it or not, companies and other places try to determine their max or min that they can do according to what are called constraints. Constraints or restrictions. And these inequalities become the constraints or the restrictions. And then they find a profit statement or an objective function that allows them to get the best profit or to maximize it, or to get the least amount of cost. And this is called linear programming. So what we're going to do is we're going to write some objective functions, write constraints, and then we're going to graph it and come up with the best scenario for the situation. Okay, here's the problem. Bottled water and medical supplies are to be shipped to survivors of an earthquake by a plane. Each container of water will serve 10 people, and each medical kit will aid 6 people. If X represents the number of bottles to be shipped, and Y represents the number of medical kits, write an objective function that models the number of people that can be helped. So we want to maximize the number of people that can be helped. Usually your objective statement will be marked with the letter Z. I can do 10 people for water and 6 people for medical kits. This is my objective function. This is the one. This objective function will tell me the maximum people I can help. So I need that. Now I need some constraints. Each plane can carry no more than 80,000 pounds. The water bottles weigh 20 pounds per container, and each medical kit weighs 10 pounds. Let X represent the number of water bottles to be shipped, and Y the number of medical kits. Write an inequality that represents this constraint. So 20 pounds for the water and 10 pounds for the medical kits has to be less than or equal to 80,000. There's my first constraint. Now let me put that down again. 20x plus 10y has to be less than or equal to 80,000. Okay, each plane can carry a total volume of supplies that does not exceed 6,000 cubic feet. Each water bottle is 1 cubic foot, and each medical kit also has one volume of 1 cubic foot. With X still representing the number of water bottles and Y the number of medical kits, write an inequality that models the second constraint. So 1x plus 1y has to be less than or equal to 6,000. Now this makes sense. A plane can only hold so much weight, and a plane can only hold so much supplies. So here are the constraints that happen. We have to add 2 more of our own constraints. And these 2 constraints are added a lot. For example, can you have negative amount of water bottles? No, so x has to be greater than or equal to 0. Can you have negative amount of medical kits? No, so y has to be greater than or equal to 0. So that means I am graphing in an L graph where x is my water and y are my medical kits. So I have to solve these for y. So 10y is less than or equal to negative 20x plus 80,000. Was it 80,000 or 8,000 when I made that move? 80. Okay, we just want to make sure it's right. Divide by 10, divide by 10, divide by 10. Y is less than or equal to negative 2x plus 8,000. So there's my first equation with constraints. Second one, move my x over, and y is less than or equal to negative x plus 6,000. And I have x has to be greater than or equal to 0, y has to be greater than or equal to 0, so I'm shading in this area. Okay, so now I need to graph. Well, I definitely cannot count by ones to get to 8,000. Do I have enough to count by 500s? 5, 1, 2, 3, 4, 5, 6, 7, 8. Yep. Let me count by 500s. So this is 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. Okay, I'm going to go down 2 and over 1. If I count it by 500s this way, I'm going to count by 500s this way too. Okay, so 6,000 down 2 over 1. Down 2 over 1, 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 down 2, down 2. Okay, I'm off somewhere. Okay, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000. I didn't go down 2 on the first one. That's why it's so hard to graph when you don't have the right equipment. Okay, down 2 and over 1, down 2 and over 1, down 2 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 over 1. Okay, on the other one, we're starting at 6,000. And we're going down 1 over 1. So we're going to go over to 6,000. They're both underneath, so we're coloring in here. Now, once we find our colored area, what we have to do is find all the vertices. So one of our vertices is 0, 0. One of our vertices is 0, 6,000. One of our vertices is 4,000, 0. The other one right here is 2,000, 4,000. Now, what do we do with those? Well, we had an objective statement back a couple slides, and our objective statement was 10x plus 6y. So what we do is we take our objective statement, 10x plus 6y, and we plug each of these in. So z is equal to 10x plus 6y. So we plug 0, 0 in. 10 times 0 plus 6 times 0 is 0. I take 0, 6,000 and I plug it in. 10 times 0 plus 6 times 6,000 means that 36,000 people would be helped. if I took no water and 6,000 medical kits. 4,000, 0, would give me 10 times 4,000 plus 6 times 0, which helps 40,000 people. So if I take 4,000 waters and no medical kits, 40,000 people can be helped. If I do 2,000, 4,000, I get 10 times 2,000 plus 6 times 4,000 gives me 44,000. So 44,000 people can be helped. So how many should I have? To maximize it, I should take 2,000 waters and 4,000 medical kits to help 44,000 people. Let's do another one. A company. A company manufactures bookshelves and desks for computers. Let X represent the number of bookshelves manufactured daily, and Y is the number of desks manufactured daily. The company's profits are $25 per bookshelf and $55 per desk. Write an objective function using Z. So Z is equal to X is the bookshelves, and it's $25, so 25X. And the desks are Y. So there's my objective function. Write a constraint. To meet customer demand, the company must manufacture between 30 and 80 bookshelves. So 30 bookshelves are X and 80 inclusive. Okay, so that means that they're equal to. And at least 10 and no more than 30 desks. So now I have two sets of vertical and two sets of horizontal lines. So 30 and 80 and 10 and 30. Okay, so let's see what we got here. We can go between 30 and 80 and 10 and 30. Oh, we missed one up here. To maintain high quality, the company should not manufacture more than a total of 80 shelves and bookshelves a day. So X plus Y has to be less than or equal to 80. X plus Y has to be less than or equal to 80. Now, because I have these constraints on how many the smallest and the largest bookshelves amount can be, I don't have to put X has to be greater than or equal to 0 or Y has to be greater than or equal to 0. So these are the three constraints I'm using. X is less than or equal to negative X plus 80. I'm still going to do an L chart. $10, $20, $30, $40, $50, $60, $70, $80. 10, 20, 30, 40, 50, 60, 70, 80. Okay, X were my bookshelves and Y were my desks. Okay, starting with this one, because I always like to do my slanted first. I start at 80 and I go down one and over one. So I'm going to hit 80 over here. Sometimes if I put dots, 10, 20, 30, 40, 50, 60, 70, 80, make it. Okay. I have horizontal lines at 30 to 80. I have vertical lines at 30 to 80, and they're solid. So I'm colored in here. And I have horizontal lines at 10 and 30, and they're solid. It's colored in here. So I'm looking at this space in here. So the vertices I'm looking at, this one, this one, this one, and that one. It's actually this one. Okay, so let's see here. 30-10, 30-30, 50-30. It's hard when I'm not graphing like totally on. 70-10. Okay, our objective statement was 25x plus 55y. 25x plus 55y. So, z is equal to 25 times 30 plus 55 times 10. Z is equal to 25 times 30 plus 55 times 30. Z is equal to 25 times 50 plus 30 times, plus 55 times 30. And Z is equal to 25 times 70 plus 55 times 10. So let's see what we get here. 25 times 30 plus 55 times 10 gives us a profit of $1,300. 25 times 30 plus 55 times 30 gives me a profit of $2,400. 25 times 50 plus 55 times 30 gives me a profit of $2,900. 25 times 70 plus 55 times 10 gives me a profit of $2,300. So, the maximum occurs here when we do 50 desks, 50 bookshelves, and 30 desks. So we're going to do 50 bookshelves, 30 desks for a profit, and that's your max profit of $2,900. And if you're a business owner and you have constraints, you want to know what your max profit's going to be so you know how to do it. You know the best setup to make the best profit because that's what you're in the business for. Now it's your turn to try.